I'm Dr. Chris Clarkson from the University of Queensland, and today I'm going to teach you how you can turn something like this, a block of rock, to something like this, a finely flaked stone tool. Okay, so the kind of rocks that we use to make stone tools with, generally speaking, at least the sort of stone tools that are chipped through percussion, are very, very fine-grained silica rocks. They can be cherts or flints like this one. They can be things we call silcrites, which are like little grains of quartz all cemented together with silica, and other kinds of rocks, even fine-grained volcanic rocks. These are sedimentary rocks, usually formed within large limestone formations, often in seabeds. And I guess they have a number of properties. One is that the crystals that actually form the rock are microscopic. You can't see them with the naked eye, so they're cryptocrystalline. Another one is that when we strike them, we want the force to run through the rock in the direction that we choose. And in other words, we're talking about isotropic rocks that don't flake in a predetermined direction. So we're actually able to control fracture so that we can fracture in any direction we choose. Those are the main properties. The other one, obviously, is that it's brittle, so that when we strike it and impart force, it breaks apart the molecular bonds and we cause a crack, which will then run the length of the flake, allowing a sharp piece to be attached. So those are the main properties of the rock that we're flaking. People used other kinds of rocks, softer rocks, particularly for making things like ground edge hatchets and axes. And by having a softer rock, you could often grind it to make a sharp edge, and also it wouldn't fracture on impact when you were chopping down trees or branches or whatever it is you were doing. The hammer that I'm using is a very, very dense rock. It's not a particularly brittle rock. This one's a quartzite, but typically people would use volcanic rocks like basalt, very dense basalt. It tends to be softer and less brittle than the rock that we're striking because we don't want the hammerstone to shatter in our hand. And it's heavy and dense because we want enough weight to be able to take off a flake. So what I'm going to make to begin with is a fairly simple kind of core and flake combination. So this is basically going to be a single platform core. It is made with just a flat surface, and then we strike off a series of flakes around the outside of this flat platform. And this is distinctive and very characteristic of early Australian core technologies. So I'll now go ahead and make a couple of flakes. What I'm doing to begin with is just brushing off the sharp edge of this platform to make a nice strong platform edge, and then I'm going to hit it hard, try and take a nice big flake off. Like so. You can see the flake that's come off here. See, I've struck it right on the edge here, and the result being a nice big flake. Has this characteristic kind of protuberance here, which we call the bulb of percussion. This is the section I struck, the platform, which fits like so. And then we end up with very strong, sharp margins all the way around. As you can see here, this is the outside surface of the rock, the cortex. And typically what stone knappers would have done would be to try and remove as much of that cortex in order to end up with just a sharp inside part of the rock right the way around the edge. Ready for another blow. Again, striking this flat surface here. And we end up with another flake. The cortex just around one edge, and a nice, very sharp stone margin here. You can sort of refit those two things together, and you can see the way flaking proceeds. We have the first flake with its cortex. We take that one off, and then the second flake, like so. Again, with its platform and its bulb of percussion. We've just produced a sharp little blade, very sharp edges, nice and elongate. Now we've got a distinctive kind of flake called a step termination, where the force that was imparted into the core with the hammer has failed to run all the way down the core face, and it's resulted in this step. And this is the way these single platform cores typically end up. Once you create these big deep steps, it's very hard to keep flaking on that platform, and the core gets thrown away.